Sorry about that. Not much in it. We got to let people do their job. All right. So, number 3, circle the one that is an empirical formula. Well, I can factor a 2 out of that. Those are all even, so that's not empirical. I told you any element that has one atom, I can no longer factor anything out of, so that is my empirical. If you have one atom of anything, like I have one atom of carbon, one atom of oxygen here, that's it. I can't factor anything out of here, so that is my empirical. I can factor a 3 out of here. I could make that CH2O. So that's not an empirical. Okay, 4 is the more interesting one. Those are pretty easy. So this is more like what's going to happen. And I set it up the same way every time. I put empirical formula mass, molecular formula, mass. I have an empirical formula, C2H4O, and I have a molar mass, molar formula mass. I write it MFM. You can write MM, that's fine. 44.06 grams per mole. So what I need to do is compare how much this weighs to how much this weighs. And that'll tell me how much bigger this is than this, or if it's bigger at all. So I have 2 carbons on 2 times 12, enter. And I have 4 hydrogens, so I'm going to add 4. And I have 1 oxygen, so I'm going to add 16. And that gives me 44 grams per mole. And over here, this is 44 grams per mole. And if the molecular formula mass is the same as the empirical formula mass, then the molecular formula is identical to the empirical formula. Okay? Let's keep going. Because hopefully this one won't be the same like that. All right, so again, I have an empirical formula mass, molecular formula, molecular mass. Empirical formula is C3H7. Molar mass is 86.2. Notice this says AMU. That's interchangeable, right? Because this is AMU or grams, so that's grams now. What is hexane's molecular formula? All right. Well, I got to have an empirical formula mass, so I have 3 carbons, 3 times 12, enter. And I'm going to add 7 hydrogens. And so I get a molecular mass or empirical formula mass of 43 grams per mole. So all I'm going to do is divide my molar mass by my empirical formula mass. I know 43 doubled is 86, so I know what's about to happen here. It's going to equal 2. That means that my molar mass is twice as heavy as my empirical formula mass. That means I have twice as many atoms. That means I can multiply all these subscripts times 2. C6H14. Done. I have a molecular formula, empirical formula. That's all they're asking for on a problem like this. Now, they can add that step into what I'm about to do. What I'm about to do is a little more complex, but they could add, well, like number 8, they did add. They added a molecular mass. Why did they not give you that in a box? Like, I don't see anything in a box for these. Oh, I see it. It's on the next page. Okay, so the last page I don't get to do anything on, so we might as well do these and figure out what we're doing. Okay, so there are 3 steps to solving going from a percent of elements to an empirical mass. I'm going to put them, let's see, where do I want to put them? I'm going to put them on a separate sheet of paper, and then we can access them when we need them. Okay, so step 1 is magic. Convert percent to grams. Right? That's step 1. Magic, convert percents to grams. Easy enough. All I have to do is go hecto. Don't look. Not yet. Wait. All right, now you can look. Grams. Look. Bang. Grams. How smooth is that, right? All right, so now we've got these things into grams. Step 2 is convert grams to moles. Now, you've been doing this a lot, and we've been doing it using this method. Okay, let's say I'm going to do this first one. I have 40.92 grams of carbon. 40.92 grams of carbon. So this is grams of carbon, and this is moles of carbon. And I know there are 12 grams in every 1 mole, and 40.92 divided by... Can we ultimately accept that this is just dividing by the molar mass to get moles? Because it's going to make our life so much easier if I can just do this. Divided by 12 grams equals moles of carbon. That's so much easier than setting up an entire dimensional analysis. This is the only place I'm going to shortcut it, but it's a good shortcut. Hydrogen, 1 gram per mole. So I'm going to get an answer for moles of hydrogen. And then oxygen, dividing by 16 grams per mole. And I'm going to get an answer for moles of oxygen. Okay, so 40.92 divided by 12 gives me 3.41 moles of carbon. Notice I did not round. I did not round to anything. You cannot round when you're doing this. I cannot emphasize how much. You cannot round while doing this. Whatever digits it spits out, that's what you're going to do. 4.58 divided by 1, I know that that's 4.58. 54.50 divided by 16. Okay, you see that big long number? I'm going to put that whole number right here. 3.40625. Okay, now I'm going to divide by the lowest mole total. In this case, it is that 3.40625. So I know that here I have a factor of 1. I'm just dividing by the lowest mole total. That is step 3. Step 3, divide by lowest mole total. And then there might be one extra step. There might not. Let's just see. Okay, so let's just push this right up here. Okay, so that's 4.58 divided by 3.40625. 1.344. No, I hate sloppy answers like this. 3.41 divided by 3.40625. Okay, in the last step, we can round to the tenths place. So I'm going to call this 1 equals 1. Now then, I have to make that into a whole number. I can't have C1 H1.34401. That can't happen. I can't have partial atoms. So what can I multiply that times to make it whole? It's going to be 2 or 3. If it's 0.5, it's 2. If it's 0.3, it's 3. So 1.344 times 3. 4.032. And I told you in this step only, you can round to the tenths place. So times 3 equals 4. Anything I do to this, I have to do to these as well. So times 3 equals 3. Times 3 equals 3. All right, so these are my subscripts for my carbon, hydrogen, oxygen. C3, this is carbon, this is all my calculations for carbon. H4, O3. They don't always turn out nice. They don't always turn out like to be nice round numbers from the get. Sometimes they'll turn into 1.5. Sometimes they'll turn into 1.333333, which you'll know times 3. It just depends. Hopefully, maybe this next one will work out nice and evenly. But anyway, this is the answer. This is my empirical formula. Let's do this next one with iron. So ecto-hecto. Don't look, don't look. Magic. They're grams. And then I need them to be moles, so I'm going to divide by the molar mass, in this case of iron, which is 55.8 grams per mole. And sulfur, which is 32.1 grams per mole. Do we see how grams cancel and I end up with moles? I should leave myself room to put an answer there. Moles of iron. Moles of sulfur. All right, let's do some math. 53.7 divided by 55.8 equals 53.7 divided by 55.8 is 0.9623. And again, I told you not to round. I'm going to save this in my calculator, and I'm going to see if it's the smallest one. If it's the smallest one, I'm going to divide by it. 46.3 divided by 32.1. 1.4423, etc., etc. So the 0.9 whatever is my smallest one. I'm going to divide by that 0.9623. This is obviously equal to 1. All right, so I'm going to do this. Answer that divided by 0.962365591. It is 1.49. I told you you could round it to the tenths in the last step. In this last step, we can round it to the tenths. So I'm dividing by 0.9623, etc., etc. And I got an answer of 1.5. That rounds to 1.5. Again, I have to make it whole, so it's times 2 or times 3. I know in this case it's times 2 equals 3. Times 2 equals 2. So it looks like I have Fe2. That's where that 2 came. The 2 goes to. S3. That's where the 3 goes to. I hope that makes sense. This is, okay, so number 8 here that I'm about to do for you is, I think it's the hardest one on the hardest type problem you will have on the test. So again, but it's no different than anything else we've done. I'm going to write the numbers down here, and I'm going to do it as neat as possible so that hopefully you get exactly what we're doing. So the first thing I got to do is convert these to grams. 71.02 grams of silver, 7.91 grams of carbon, 21.07 grams of oxygen. And then I'm going to divide by their molar mass. Oxygen, 16 grams per mole. Carbon, 12 grams per mole. Silver is 107.9 grams per mole. And then I'm going to come up with moles of silver, moles of carbon, and moles of oxygen. All right, it's math time. 71.02 divided by 107.9 equals 0.658, etc., etc., etc. I'm going to save that in my calculator in case I need it. I'm going to do it to 3 digits. Actually, I'm going to do it to 4 digits here. All right, 7.91 divided by 12. 0.6591666, etc. And then oxygen, 21.07 divided by 16. 1.316875. All right, so I'm dividing by the lowest. The lowest is 0.6582. That's going to be equal to 1. Divided by 0.6582. That's going to be equal to 1 and some other numbers, but 1. If I enter that in the calculator, 0.6591 divided by 0.6582. And what did I do? Oh, I'd put, okay. 0.6591 divided by 0.6582. I get that number, which is 1, right? And then 1.31 divided by 0.6582. 1.31687 divided by 0.6582, enter, equals, you can round to the tenths in this last spot, equals 2. Therefore, my empirical formula is AgCO2. That's my answer. Empirical formula up here. Sorry, I didn't specify that. Okay, guys, that's it. That's all I'm allowed to show you, apparently. So that's all the types of questions that'll be on the test. Big things to remember. Remember these steps. You got to remember these steps. You got to remember 2 conversions. 1 mole equals 6.02 times 10 to the 23rd. Atoms, molecules, whatever. And that 1 mole equals molar mass in grams of whatever element. And okay, so we got to remember these steps. We got to remember these conversions. And we got to remember the rules for dimensional analysis. And that is whatever the units here are, the units here are. Whatever the units of my answer I'm trying to get, back into this spot. And I know if I write mole in this box, either on top or bottom, it's 1. 1 mole, ever. Okay? I hope that helps. If you have any other questions, send them to me via my Remind. If you're my student, if you're not, I'll be here at 6 a.m. tomorrow. You can ask anything you want. Bye, guys.